Hi everybody. So this lesson is about different types of transformers, and there are actually three types of transformers. But before I talk about the three types of transformers, I just want to show you what is the symbol that we use to represent a transformer in a circuit. Now, a coil of wire, so I'll just do it over here. So transformers consists of two coils. So this is one coil. This is the other. Okay, so that's a symbol for a transformer, and to show that it's got an iron core, we draw a line in between. So that means it's an iron core. Now the iron core can be of different types. If the iron core is in powder form, then it's a dotted line like this. Okay, so a line between says it's got an iron core, just to increase the efficiency. So that's a symbol for a transformer. Okay. Now, there are three types of transformers. So one is called the step-up transformer. Then there's what's called the step-down transformer. And then there's what's called the isolating transformer. Okay? Now, just from the words, it becomes quite evident. So if you want a higher output, then you have what's called a step-up transformer. So how is a step-up transformer different from the other two? Now, in a step-up transformer, the number of turns of the primary is less than the number of turns of the secondary. When the number of turns of the primary is less than the number of turns of the secondary, then you also have the voltage across the primary is less than the voltage across the secondary. So you're going to get a bigger voltage output. Okay, so what you get for a step-up transformer is a higher output voltage. All right. Okay, let's do this step-down transformer. So in a step-down transformer, there's more number of turns in the primary. So the red ones are all the primary coils, the blue are all the secondary. Okay, so that's your primary, that's your AC source. So the number of turns of the primary is greater than the number of turns of the secondary. So the voltage across the primary is greater than the voltage across the secondary. So if you want a lower output voltage, then you have a step-down transformer. Now, lots of our gadgets actually have, the little black box that connects from your, the cable that you put onto your laptop. Let me see if I can show you one. Yeah. Okay. I don't know. Oh, it's not long enough. Okay. There's a little black box. I tried to reach out, but it's not high enough for the camera. But they have in them transformers because the voltage that you get from the mains is 240 volts, and a lot of our electronic gadgets don't need such high voltages. They work at much lower voltages. So what a step-down transformer does is it steps down the voltage to whatever you need. Okay. All right. And also, if you're migrating from New Zealand to America or America to here, they use a different amount of voltages for all their gadgets. Even the voltage in the mains, I think it's 110 and not 240. So you need to have these adapters so that your appliances can work safely. All right. Okay, so that's a step-down transformer, and for a step-down transformer, you have a lower output voltage. So you have a lower output voltage. Okay. And then in the middle, you have what's called an isolating transformer, and I'll tell you why we use that. In an isolating transformer, the number of turns of the primary is equal to the number of turns of the secondary. The voltage across the primary is equal to the voltage across the secondary. So you think, oh, so then why do we need one at all? Now the word isolate is to set apart and not mix it up with anything else. So an isolating transformer is used to prevent electric shocks, and these are used where gadgets are in places where they could get wet, like things in the bathroom, like a shaver in the bathroom, or anything where you have to plug it in and there's moisture in the bathroom. So to prevent, for a safety device, so to prevent electric shocks, you have what's called an isolating transformer. Okay, so you've got three types of transformers: step up, step down, and isolating, and you can get what you need by controlling the number of turns of the secondary and the primary, because they're related to the voltage across a primary and secondary. And just to bring in mind, the formula that we use is NP by NS equals Vp by Vs, and that's the formula that we use for any of these. So if you know 3 things, you can calculate the 4th thing. Okay, now there are a couple of things I'd like you to do once you've gone through and understood this thing on transformers. So the first thing I'd like you to do is, on page 4 there are some notes on transformers. Could you just read through that and highlight what's important? And then on page 7 in your booklets, or you don't have the booklets, but I've sent you the PDF copies, there is like a worksheet on transformers. So what I'll do is I'll work through it and take a photo and upload it for you to check. So just read through it. It really explains it beautifully. And once you've done those, then we can finish the rest of the questions on mutual inductance, and that is on your question sheet. And so we did 1 and 2 when we learnt mutual inductance, and I said not to do 3, 4 and 5 because they're based on the transformers. So if you can do 3, 4 and 5, we are all done for this lesson. I hope you understood, and if you have any doubts, just put that in the queries column and I will sign off. Bye for now.